Hello! In this video, we will solve the equation cosecant of 2x minus 2 sine of 2x equals 1, and we will find the values of x on the interval from 0 to 2 pi. To solve this equation, we will use the reciprocal identity cosecant of theta equals 1 over sine of theta, and we will replace cosecant of 2x with 1 over sine of 2x. So then, we will write that 1 over sine of 2x minus 2 sine of 2x equals 1. Next, we will multiply both sides by sine of 2x to eliminate the denominator. Then on the left side, we will use the distributive property, and we will have 1 minus 2 sine squared of 2x equals sine of 2x. Next, we will move all the terms to one side, and we will have 2 sine squared of 2x plus sine of 2x minus 1 equals 0. Now the equation has 3 terms on one side, and we will make the following substitution. We will replace each sine of 2x with the letter b, so b equals sine of 2x. Then we will have 2b squared plus b minus 1 equals 0. And now to solve this equation for b, we will factor the left side using the AC method. And this method involves the sum, the product, and grouping. So we will need to find two numbers whose sum is 1, and 1 is the coefficient of b, and the product is negative 2. And to get this negative 2, we multiply 2 and negative 1. Then these numbers will be positive 2 and negative 1. And this is because 2 plus negative 1 is 1, and 2 times negative 1 is negative 2. And now we will use these two numbers to split the middle term b into 2b minus 1b. So then we will write 2b squared plus 2b minus b minus 1 equals 0. Then once we have 4 terms, to factor we will use grouping. We will group the first 2 terms together, and then the last 2 terms. Then in the first group, we will factor out 2b, and in parentheses we will have b plus 1, and in the second group, we will factor out negative 1, and in parentheses we will also have b plus 1. Then if we factor out b plus 1, in the second parenthesis we will have 2b minus 1. So this 2b and minus 1 comes down into the second parenthesis. And now we will use the zero product property to set each factor equal to 0. So we will write that b plus 1 equals 0, or 2b minus 1 equals 0. Then in the first equation, b equals negative 1, and in the second, b equals positive 1/2. Now in the next step, we will replace each b with sine of 2x. So the first equation will be sine of 2x equals negative 1, and the second, sine of 2x equals 1/2. And now to solve each of these equations, we will use the unit circle. So let's start with the first one. On the unit circle, we need to find all the angles where the value of sine is negative 1/2. And recall that the first coordinate of each point represents the value of cosine, and the second coordinate the value of sine. And so far, we see that sine is negative 1 when the angle is 3 pi over 2. So we will write that 2x equals 3 pi over 2. So the input here is 2x, and so far we found one angle where sine is negative 1. Now, if from 3 pi over 2 we add or subtract 2 pi as many times as we want, then the value of sine will also be -1. So to 3 pi over 2 we will add 2 pi multiplied by an integer k. And now to solve this equation for x, we need to divide both sides by 2. Then we will have x equals 3 pi over 4 plus pi times k. And now we need to find all the values of x on the interval from 0 to 2 pi. So let's start by replacing this k with 0. X equals 3 pi over 4 plus pi times 0, and this will be equal to 3 pi over 4. And this is the first solution we found on the interval from 0 to 2 pi. Next, we will go and replace k with 1, and we will have x equals 3 pi over 4 plus pi times 1, and this will be equal to 7 pi over 4. So this is the second solution we found. And this is how far we will go with the first equation, because now if we replace k with 2, then the number we will get will be greater than 2 pi. Now let's continue with the second equation. Sine is 1/2 when the angles are pi over 6 and 5 pi over 6. And if from these angles we add or subtract 2 pi as many times as we want, then for all these angles, sine is also 1/2. So then we will write that 2x equals pi over 6 plus 2 pi times the integer k, and the second equation will be 2x equals 5 pi over 6 plus 2 pi times k. Then in the first equation, to solve for x, we will divide both sides by 2. Then x equals pi over 12 plus pi times k. And now to find the values of x on the interval from 0 to 2 pi, we will start by replacing k with 0. Then x equals pi over 12 plus pi times 0, and this equals pi over 12. Next, we will replace k with 1, and we will have x equals pi over 12 plus pi times 1, and this equals 13 pi over 12. And now if we would replace k with 2, then this number would be greater than 2 pi. So here we found two solutions, and now we will move to this equation. We will start by dividing both sides by 2. Then x equals 5 pi over 12 plus pi times k. And now to find the values of x on the interval from 0 to 2 pi, we will start by replacing k with 0. So we will have 5 pi over 12 plus pi times 0 equals 5 pi over 12. Next, we will replace k with 1. So we will have x equals 5 pi over 12 plus pi times 1. And this equals 17 pi over 12. And now let's write the solution set from the smallest to the largest. First we will have pi over 12, then 5 pi over 12, then 3 pi over 4, then 13 pi over 12, then 17 pi over 12, and the last one will be 7 pi over 4. And now the problem is completed. Thank you for watching.